They deleted a third of their AI's brain, and it got smarter. So let me ask you something that should keep you up at night. What if the entire Western assumption about artificial intelligence, that bigger always means better, that more parameters equal more power, that the team with the most compute wins, is not just wrong, but dangerously, strategically wrong? That is the question sitting at the center of what just happened in China. And most people in the AI industry, let alone the general public, have barely noticed. In early March of 2026, a research lab called Yuan Lab, part of Inspur, one of China's largest server manufacturers, quietly released a model called Yuan 3.0 Ultra. On the surface, the name sounds like every other incremental AI release that floods the news cycle. Another version, another benchmark, another press release. But underneath that unremarkable name is something that fundamentally disrupts the logic that has governed the artificial intelligence industry for the last 5 years. Yuan 3.0 Ultra started its life as a model with 1,515 billion parameters. A number so large it is genuinely difficult to hold in your mind. For context, a parameter is roughly analogous to a single weighted connection in the model's neural network, a single knob in the vast machinery of its cognition. Most frontier models today operate in the hundreds of billions. 1.5 trillion is extraordinary. And then the engineers at Yuan Lab did something almost nobody does at that scale. They deleted 505 billion of them on purpose during training, and the model performed better afterward. Let that land for a moment. They threw away 1/3 of a trillion parameter AI and got a faster, more efficient, more deployable system on the other side. This is not a story about one Chinese AI model. This is a story about a fundamental shift in how artificial intelligence gets built, who gets to deploy it, and whether the West's strategy of racing toward infinite scale is actually a winning hand or a trap. To understand why this matters so deeply, you need to understand the architecture sitting underneath Yuan 3.0 Ultra. The model uses what is called a mixture of experts design, MOE for short. Unlike a dense model, where every single parameter activates for every single token of text you feed it, a mixture of experts model routes each token through only a small subset of specialized subnetworks called experts. Imagine a vast hospital. When you walk in with a broken arm, you do not consult every doctor on staff. You get routed to orthopedics. The hospital is massive and full of specialists, but at any given moment, only the relevant ones are actually working on your case. That is the genius of MOE architecture. Yuan 3.0 Ultra has over 1,000 experts embedded across 103 transformer layers. But at any given moment, only 68.8 billion parameters are actually active and burning compute. The rest are sitting idle, waiting for their specialty to be needed. Here is the surprising fact almost nobody outside of machine learning research has internalized. In a mixture of experts model trained at scale, those experts are not equally useful, not even close. The Yuan Lab researchers discovered something remarkable when they analyzed their model mid-training. During the early volatile phase of training, when random initialization creates chaos in the routing system, token loads across experts fluctuate wildly. But once training stabilizes, the imbalance does not resolve. It crystallizes. A small number of experts absorb an enormous share of the computational load. The rest become passengers, present on the manifest, but barely doing any work. And here is the number that should shock you. The disparity between the highest load experts and the lowest load experts in a trillion parameter MOE model can reach nearly 500 times. Not 50% more, 500 times more. Some experts were routing almost nothing. They were dead weight, carrying the costs of memory, storage, and communication overhead without contributing meaningfully to the model's intelligence. So Yuan Lab built an algorithm to find them and remove them. They called it Layer Adaptive Expert Pruning, LAEP. It watches the model's behavior across layers during the stable phase of training, identifies which experts are chronically underutilized, and eliminates them layer by layer. Then it runs a second pass, a rearrangement algorithm that redistributes the remaining experts across computing hardware to keep loads balanced. The result was a reduction from 1,515 billion parameters down to 1,010 billion, a 33.3% cut. And the efficiency gain was not modest. The training performance per GPU jumped from 62 teraflops to 92 teraflops, a 49% improvement in raw computational throughput. They deleted a third of the model, and the training hardware became almost 50% more productive. That is not an optimization. That is a different paradigm. Here is the thesis of this entire episode, and it is one sentence. The future of frontier AI does not belong to whoever can accumulate the most parameters. It belongs to whoever can find the most intelligence inside the fewest activated ones. And right now, China is operating on that insight, while much of the Western AI establishment is still racing in the other direction. What is actually happening here runs 3 layers deep, and each one matters. The first layer is technical. Yuan 3.0 Ultra, with its 1.01 trillion total parameters and 68.8 billion activated, is not just efficient in training, it is designed to be deployable. The model comes in a 4-bit quantized format, which means enterprises can compress its memory requirements dramatically and run it on smaller, more affordable GPU clusters. The model supports 64,000 token context windows. It is open source, available on GitHub, Hugging Face, and ModelScope. Any organization on the planet can download, fine-tune, and deploy it commercially without paying a licensing fee or routing sensitive data through a foreign company's API. The weights are yours. The intelligence is yours. The second layer is what it actually does in the real world. The benchmarks Yuan Lab published are not abstract reasoning puzzles designed to flatter large models. They are enterprise benchmarks, tests that mimic what corporations actually need AI to do. On Docmatics, a multimodal retrieval benchmark that simulates pulling information from complex documents containing mixed text and images, Yuan 3.0 Ultra scored 67.4%. GPT-4o scored 56.8%. Claude Opus, the flagship model from Anthropic, scored 46.2%. Gemini 3.1 Pro scored 35.3%. That is not a marginal lead. That is a different category of performance on exactly the kind of task that drives billions of dollars in enterprise AI spending. On ChatRag, a benchmark for retrieval augmented generation across text knowledge bases, the backbone of internal corporate AI assistants, Yuan 3.0 Ultra scored 68.2%, ranking first on 9 out of 10 subtasks. GPT-4o scored 50.5%. For document summarization, text-to-SQL database query generation, and knowledge extraction from financial reports and technical proposals, this model is not competing with Western AI. In these domains, it is leading it. The third layer is what most people are completely missing. This is not just a technical achievement, it is a geopolitical one. Inspur, the company behind Yuan Lab, is one of the largest AI infrastructure providers in the world. They build the servers, they run the data centers, they understand at a hardware level what it costs to deploy intelligence at scale. And they built Yuan 3.0 Ultra with that cost structure in mind. When you eliminate 33% of your parameters mid-training and increase compute efficiency by 49%, you are not just saving money in the lab. You are changing the economics of who can afford to run frontier AI. A quantized trillion-parameter model that can run on smaller GPU clusters is not just accessible to hyperscale cloud providers. It is accessible to mid-sized enterprises, government agencies, academic institutions, and organizations in markets that cannot afford OpenAI's API costs. That is a massive strategic play for global AI adoption. And China just made it. Now, the strongest opposing argument deserves a fair hearing. Some will point to the benchmarks where Yuan 3.0 Ultra does not dominate and conclude that Western models are still ahead in general intelligence. And that argument is not without merit. On the BFCL v3 benchmark for dynamic tool invocation, a task that matters enormously for complex agentic AI systems that need to call APIs and external services in real time, Yuan 3.0 Ultra scores 67.8%, while Gemini 3.1 Pro scores 78.8%. On the BIRD text-to-SQL benchmark, which tests performance against genuinely complex real-world database schemas, Yuan 3.0 Ultra scores 39.2%, slightly trailing Kimi K2.5 at 43.5%. These are real gaps. They matter. For organizations building sophisticated multi-step AI agents that need to orchestrate tools, execute live API calls, and navigate enterprise-grade database complexity, Yuan 3.0 Ultra is not the complete solution. Not yet. But here is why that argument ultimately misses the point. The people making it are grading on a curve that was designed for a previous era of AI deployment. They are measuring generalist reasoning and agentic orchestration, tasks that matter enormously in research environments and consumer chatbots, while underweighting the specific capabilities that drive the most immediate enterprise value. The bulk of corporate AI spending in 2026 is not going toward building autonomous agents that self-direct complex multi-step reasoning chains. It is going toward document understanding, knowledge retrieval, report summarization, and database query automation. It is going toward the exact workflows where Yuan 3.0 Ultra wins. The benchmark gaps exist. They are worth watching. But they do not undermine the central fact that for the majority of what enterprises are actually buying AI to do today, this model performs at or above the level of the most expensive proprietary models on the market, for free. And now the single most powerful point of this entire episode, the one that reframes everything. The LAEP algorithm is not just a pruning technique. It is a proof of concept for a fundamentally different theory of intelligence in large neural networks. The prevailing assumption in AI scaling has been that parameters are inherently valuable, that the route to better models is through more of them, and that redundancy is an acceptable cost of scale. What Yuan Lab discovered and proved empirically on a model larger than almost anything else publicly available is that redundancy is not a cost. It is a failure mode. A model loaded with underutilized experts is not a smarter model, it is a bloated one. And the process of finding those deadweight nodes and removing them, of forcing the intelligence to concentrate into fewer, harder working components, actually makes the model reason better, train faster, and deploy cheaper. Think about what that means for the next generation of models. If you can start training at 3 trillion parameters, identify and prune 1 trillion of them mid-training, and arrive at a 2 trillion parameter model that is denser, faster, and more capable than if you had trained at 2 trillion from the start, the implications for AI scaling law are staggering. Yuan Lab has not just built a better model. They have discovered that the most powerful thing you can do to a large model may not be adding to it. It may be knowing what to take away. Here is where we land. We are in the middle of a story that most people are telling wrong. The Western narrative about AI competition frames it as a race to accumulate. More compute, more data, more parameters, more investment. And China is playing a different game entirely. They are asking a different question. Not how big can we make this, but how little do we actually need? Yuan 3.0 Ultra is the answer they built to that question. A trillion parameter model that deleted its own dead weight, became 50% more efficient in the process, beats GPT-4o on the benchmarks enterprises actually care about, and gives the whole world access to the result for free. The next time someone tells you that the AI race is about who has the most resources, remember this. The team that won the efficiency battle did it by throwing away 500 billion parameters and never looked back.